Okay, good morning, class. You have a guest teacher today. So I decided we are going to talk about Pythagorean theorem today, particularly because this is a subject that many of you have already learned or have at least seen before. And so my hope is that it will come back pretty quickly. Okay, let's get right into it. You should be looking at this page of notes. It says Pythagorean theorem notes right here at the top. And these will go pretty fast. So, we're going to do this in parts because we need to develop a couple of skills before we can actually use this thing that's called the Pythagorean theorem. The first part is we need to know how to identify parts of a right triangle. So when I'm looking at a right triangle, this is a right triangle right here. Right triangles are just triangles that have right angles. Okay, so this is a right angle right there. The right angles are marked with these little box corners. It just means that this angle here is a 90-degree angle. Okay, so right triangles have 90-degree angles. And in right triangles, the longest side is called, we have a special name for it, it's called the hypotenuse. And the hypotenuse always lives right across, exactly opposite or across from that 90-degree angle. So it's very easy to find the hypotenuse. So it is always opposite the right angle. Okay, so here we have the hypotenuse, and we have names for the other two sides. We call those the legs. So the hypotenuse, the longest side across the right angle, and then we have our legs, two legs. Okay, so we're going to practice really quickly just labeling the sides of these triangles. So for example, we have our right angle right here. And so opposite from that is where we have our hypotenuse. And that would mean that the other two sides, both this side and this side, we will call those legs. Those are legs. Okay, easy enough. Let's do the next one. Again, here I have my right angle, and right across from it, my hypotenuse. Meaning that these other two sides, this leg and this is a leg. So I always start with identifying my hypotenuse. Okay, last one. Here, one more right triangle. Right across from the right angle, we have our hypotenuse. Meaning that this is a leg and this is a leg. Okay, easy peasy. That's our first skill, skill A. Just knowing how to identify the different parts of the right triangle. Skill B. Well, I'm going to introduce what the Pythagorean theorem says about right triangles. By the way, okay, so we're introducing the Pythagorean theorem, although most of us have seen this before. By the way, this word here, theorem, it has a definition, which is a theorem is just any mathematical statement that has been proven to be true. And so the Pythagorean theorem is a very, very old theorem that we have some of the most ancient mathematical proofs for. So that's pretty neat. It's thousands of years old. Okay, so what does the Pythagorean theorem say? In plain English, as best as it can be said, called plain, The Pythagorean theorem states that in any right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. Okay, that sounds really confusing. It's better, I think, to look at that in math instead of in English. So here it says the same thing. A squared plus B squared equals C squared, where A is a leg, B is a leg, and C is the hypotenuse. And, well, what's the purpose of the Pythagorean theorem? Well, what we're going to use it for is we're going to use it to find missing sides. Because if I know both legs, then I can plug those in to find the hypotenuse. Or if I know like one leg and the hypotenuse, I can plug those in to find the other leg. And then this is what I want to really make sure that everybody understands, which is that this theorem is only true for right triangles. Only for right triangles. Okay, we're not going to use it for any other kinds of triangles. It only works for right triangles. So if I have these little markers indicating that that's a right angle. Okay, so when we're doing Pythagorean theorem, we have this formula. The A stands for leg. The B also stands for leg. And the C, well, the C is going to stand for the hypotenuse. So we reserve the letter C for the longest side, the hypotenuse. And so what we're going to practice in this next section is just labeling each side of the triangle using the letters A, B, and C. So, okay. Well, here's my right angle on this first one. Across from that is where my hypotenuse is. And notice, we're going to use the letter C for the hypotenuse. So here we have the hypotenuse. That means that the other two sides, right here and right here, those are the legs. And for that, I can call those A and B in any order. It doesn't matter. So I could have also called this B and this A. Just as long as A and B are legs, it doesn't matter which order. So let's do that again. Again, here I have my right angle. Across from it, my hypotenuse C. That would make the other two sides A and B in either order. Lastly, one more. Here, I got my right angle. And across from it, I have my hypotenuse C. And the other two sides are my legs. You might be thinking, wow, Miss Nelson, that's easy. Yep, I know. I think it's very useful, though, for what we're about to do. Your first step when approaching a problem should be to label the sides A, B, and C. Okay, does it matter which leg that gets A? No. Does it matter which leg gets labeled B? No. So the legs, only the legs can get labeled in any order. What about C? Does it matter which side I label C? Yes. Yes, it definitely does. C is only used for the hypotenuse. Okay. All right, so now we have the skills that we need to be able to move forward with using the Pythagorean theorem. So you should be now at the end of the first page of notes and hopefully turning over to the next page where the top of it will say C, using Pythagorean theorem to find missing side lengths. And once you get there, we will get started. Oh, I need to erase this really quickly. Okay, we're at the top of the next page. And what it says is we're going to use the Pythagorean theorem. Again, our goal is to use it to find missing side lengths. How are we going to use it? Well, when the problem is going to give us two side lengths, any two side lengths, I can find the unknown side by plugging in the sides I do know into my equation. A squared plus b squared equals c squared. It's not too bad. We just need to be careful to make sure that when we try to solve for the missing side, to follow the order of operations, PEMDAS, as we know we're supposed to do. So you need to make sure, because this is an equation that features exponents. So when you're dealing with it, you need to make sure that you do the exponents first before you do any addition or subtraction that might need to happen. Okay. So we're going to practice. We're going to walk through a couple problems together here. All the way. So again, first thing I do, so step 1, label sides. Okay. Well, here's my right angle. Across from it I have my hypotenuse. And we're going to use C for hypotenuse always. And that means I can call the other sides A and B in any order. Okay, step 2. Plug in to our equation. That's the A squared plus B squared equals C squared. Okay, so for this example, again, I've got A squared plus B squared equals C squared. Well, my A is 3, so I'm going to replace this A here with a 3. My A is 3. My B is 7, so replace this B here with 7. Okay? I'm just plugging the values that I have into my equation. And I don't know what C is yet. I'm going to figure it out. But right now I don't know what C is, so I'm going to leave C as is. Now, step 3 is basically just simplify and solve. And so we're dealing with an equation, which we've gotten really good at dealing with so far this year, where we're going to solve for a variable. In this case, we're solving for C. So here we go. I'm going to zoom back in here. Okay, remember, order of operations. I got to do exponents first. So 3 squared is 9. 7 squared is 49. And again, if you don't know that, that's a good use for a calculator for sure. So don't, especially for this, don't be afraid to use your calculator. Calculator is a good tool. So we did exponents first. And now we can do our addition. So 9 plus 49 is 58. And we have 58 is equal to c squared. Drag this down a little bit. Okay, we have a slight issue, which is I know that c squared is 58. How do I find c just by itself without the square? Well, I need to do square root to undo the exponent. Yes? If I square root c squared, I'll get c. So if I take the square root of c squared, well, that's c. Okay. So that's what I would like to do. I'd like to take the square root of that. And because I am an algebra expert, as you all are now, I know that when I do something to one side of the equation, I have to do it to the other side of the equation also. So I'm going to end up with the square root of 58 is equal to c. That's what c is equal to. And if you wanted to, you could plug that in a calculator and get an exact answer. But I don't really care. If you want to leave it as the square root of 58, that is fine with me. Okay, I'm going to leave this up for a second. Or we can, this would be a good time to pause the video if students need to catch up writing. Okay, let's go on to the next problem. And again, we're going to follow some steps. So here's our steps. Step 1, label the sides, A, B, and C. Step 2, plug in all the values that you have into a squared plus b squared equals c squared. And step 3 is simplify and solve. So here we go. We're going to repeat the process on this problem here. Okay. All right, again, here's my right angle. Across from my right angle is where my hypotenuse is always going to live. And the hypotenuse is always going to be C. The other two sides are going to get A and B in any order. And then I have this equation. A squared plus B squared equals C squared. Okay. Well, A is 12. So let's plug in 12 into A. Yes, A is 12. B is X. So we actually will go ahead and exchange the letter B for the letter X to represent that it's this sort of value here, this value X. And lastly, C is 13. So we will plug in 13 into Z. And now we can solve. So we need to handle these exponents first. Remember, PEMDAS. Order of operations. First thing before anything is I got to deal with these exponents. So 12 squared is 144. I don't know what x squared is because I don't know what x is yet. 13 squared is 169. Okay. Now I have an equation. I'm trying to get x by itself. So let's move 144 over to the other side. So the opposite of addition is subtraction. we'll go ahead and minus this 144 from both sides of this equation. These are going to cancel out. And I'll have x squared is equal to 169 minus 144, which is 25. Okay, so again, we dealt with our sort of subtraction that we had to do second because of order of operations. And we just have one more step we need to do, which is that if I want to undo this sort of exponent here, I need to use the square root to undo x squared. That's the inverse. Just like addition is the inverse of subtraction, these two things are also inverses. Okay? So, if I want to find x, I need to take the square root of x squared, and so I have to take the square root of both sides, and that will give me x equals, and I happen to know the square root of 25 is 5. If you don't know that, again, that's an excellent thing to put into a calculator to get an answer. Okay, again, leave this video, up for just a moment. Maybe pause the video, ask students if they have questions, let students catch up writing, and we're just going to do one last problem. Okay. We're going to do one more problem, and then you're going to practice some on your own. So, we're going to go through our 3-step process. Step 1, label sides. Okay. Well, here's my right angle. Right across from that is my hypotenuse, C. And my other two sides are A and B. So I have step 1 done. I've labeled my sides A, B, and C. Step 2, I need to plug in to this equation. Okay, well, A is 4. Yes, we're going to plug in 4 in for A. B is 8. So let's plug 8 in for B. B is 8. And I don't know. I don't know what C is. We'll leave C as a variable C. Okay. All right. So let's see. So far, we did step 1. We did step 2. And we did step 3. We've just done step 1 and step 2. Now we're on step 3. We got to simplify and solve. So again, let's deal with our exponents first. Okay, 14 squared is 16. Again, if you don't know that, calculator. 8 squared is 64. Okay, exponents done. Now I can add these together. 16 plus 64 is 80. Okay, almost there. I want to get C by itself, just C. So, I will need to take the square root of both sides. And what I'm going to obtain here is basically that C is equal to the square root of 80. Now, normally we would just stop here. But because the activity you're going to do today relies on you to remember something from first semester. So I'm going to remind you of that right now. But this hopefully is something you remember learning not that long ago, just a few months ago. And we're going to simplify this further. Simplify this square root of 80. Okay, so remember, we have these factor trees. Okay, where we're going to get 80 all into prime factors. So let's start with 4 and 20. 4 times 20 makes 80. Okay, well, remember, prime factors is like 1, 2, 3, 5, 7, 11. Numbers that I can't like divide anything into evenly. Okay, but 4 is not a prime factor because I can divide 4 by 2 and 2. So 2 times 2 gives me 4. Okay, but 2 is a prime factor. So on this side of the tree, I'm done now. Hopefully some of this is feeling slightly familiar from semester 1. Okay, 20 can also be factored further. Let's factor 20 into 2 and 10. Okay, 2 is done, but 10 can be factored further. 10 is an even number, so we can factor 10 into 2 and 5. Okay, why do this? Well, remember, we're looking for pairs. So we're looking for pairs of factors. So, for example, these 2's make a pair. These 2's make a pair. This 5 is all by itself. So, if you remember, what I said all the way back last semester is when I have these pairs of factors, we get to escape. We get to escape the radical. This is the radical here. And so, the square root of 80 becomes 2 times 2 times the square root of 5, okay? When I have a pair, one of them gets to escape. When I have a pair, one of them gets to escape. When I have a singleton, the singleton is stuck underneath the radical. It does not get to escape. Okay. I'll say that one more time because I know it's been a while. When I have a pair, one of them gets to escape. When I have a pair, one of them gets to escape. When I'm stuck with a singleton here, it gets stuck underneath the radical and just stays there. And so we can simplify this one step further because 2 times 2 is 4. And so what we have is that this missing side right here, C, is equal to 4 times the square root of 5. And again, if you want to get an exact answer for that, you need a calculator. But you need to sort of recall how to do this for this worksheet that you're about to get. So if you have questions, look back in your math notebooks. We did this last semester. Okay, I'm going to stop recording.